The National Electrical Code, specifically Section 500.8 AON, addresses temperature requirements for Class 1 equipment installed in hazardous locations. The code mandates that Class 1 equipment should not have any exposed surface that operates at a temperature exceeding the ignition temperature of the specific gas or vapor present in that location. This requirement is not an error, but a critical safety measure designed to prevent explosions and fires. The ignition temperature of a gas or vapor is the minimum temperature at which that substance will ignite spontaneously under normal atmospheric conditions without an external ignition source, such as a spark or flame. If the surface temperature of electrical equipment exceeds this ignition temperature, it can act as the ignition source, leading to a hazardous explosion or fire. The principle behind this regulation is that the equipment's surface temperature must remain safely below the ignition temperature of the surrounding flammable substances to prevent accidental ignition. Consider a scenario where a piece of electrical equipment is installed in a Class 1, Division 1 or 2 location where a specific flammable gas is present. If the equipment's surface temperature reaches or exceeds the ignition temperature of that gas, the gas will ignite, potentially causing an explosion. Therefore, the NEC requires that the maximum surface temperature of the equipment be below the ignition temperature of the gas. It is important to differentiate between the ignition temperature and the auto-ignition temperature. These terms are often used interchangeably, but they refer to the same concept. The ignition temperature is a property of the flammable substance, while the temperature rating of the equipment is a characteristic of the equipment itself. The equipment's temperature rating indicates the maximum surface temperature that the equipment will reach under normal operating conditions. This temperature rating must be below the ignition temperature of the flammable substance present in the hazardous location. Compliance with this regulation is essential for ensuring the safety of personnel and property in hazardous locations. It requires careful selection of electrical equipment with appropriate temperature ratings and thorough knowledge of the flammable substances present in the area. The NEC provides guidelines and requirements for selecting equipment and determining temperature ratings to ensure compliance with safety standards. It is vital to understand that even a slight exceedance of the ignition temperature can trigger an explosion. Therefore, a conservative approach is necessary when selecting equipment for hazardous locations. Equipment should be chosen with a temperature rating significantly below the ignition temperature of the flammable substance to provide a safety margin. The NEC classifies hazardous locations based on the type of flammable substance present and the likelihood of its presence in an ignitable concentration. Class 1 locations are those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 1 locations are those where the hazardous substance is present continuously, intermittently, or periodically under normal operating conditions. Division 2 locations are those where the hazardous substance is present only under abnormal conditions such as equipment failure or accidental release. The requirements for equipment installed in Class 1, Division 1 locations are stricter than those for equipment installed in Class 1, Division 2 locations. In Division 1 locations, equipment must be explosion-proof, meaning that it is designed to contain any internal explosion and prevent it from igniting the surrounding atmosphere. In Division 2 locations, equipment can be either explosion-proof or intrinsically safe, meaning that it is designed to limit the energy available to a level that isn't sufficient to ignite the flammable substance. The temperature rating of equipment is typically marked on the equipment itself, along with other information such as the class and division for which it is approved. This temperature rating is expressed as a temperature code, which is a letter followed by a number. The letter indicates the maximum surface temperature of the equipment, and the number indicates the class and division for which it is approved. For example, a temperature code of T3C indicates that the equipment has a maximum surface temperature of 160 degrees Celsius and is approved for use in Class 1, Division 1 and 2 locations. It is important to consult the NEC and other relevant standards for detailed information on temperature ratings and equipment selection for hazardous locations. These standards provide specific requirements and guidelines for ensuring the safety of electrical installations in these areas. Furthermore, the specific flammable gas or vapor present in the location must be identified, and its ignition temperature must be known. This information can be obtained from safety data sheets or other reliable sources. Once the ignition temperature is known, equipment can be selected with a temperature rating below that temperature. The NEC also addresses the issue of temperature rise in electrical equipment. Electrical equipment generates heat during operation, and this heat can cause the surface temperature of the equipment to rise. The NEC requires that the temperature rise of equipment be taken into account when determining the overall temperature rating of the equipment. The temperature rise is the difference between the ambient temperature and the maximum surface temperature of the equipment under normal operating conditions. The NEC provides guidelines for determining the temperature rise of equipment and for ensuring that the overall temperature rating of the equipment is below the ignition temperature of the flammable substance. In addition to temperature ratings, the NEC also addresses other aspects of equipment design and installation in hazardous locations, such as grounding, bonding, and sealing. These requirements are designed to prevent explosions and fires by minimizing the risk of electrical arcs and sparks. Grounding and bonding are used to ensure that all metal parts of the electrical system are at the same electrical potential, which reduces the risk of electrical shock and minimizes the potential for electrical arcs. Sealing is used to prevent flammable gases or vapors from entering electrical enclosures, which can reduce the risk of explosions. Compliance with all of these requirements is essential for ensuring the safety of electrical installations in hazardous locations. The NEC is a complex and comprehensive document, and it is important to consult with qualified electrical professionals to ensure that electrical installations in hazardous locations are compliant with all applicable requirements. These professionals have the knowledge and experience necessary to select and install equipment properly and to ensure that the installation is safe and reliable. Proper training and education are also essential for personnel working in hazardous locations. These individuals should be trained in the hazards associated with flammable gases and vapors and in the safety procedures necessary to prevent explosions and fires. Training should include information on the NEC requirements for equipment selection, installation, and maintenance, as well as procedures for responding to emergencies. Regular inspections and maintenance are also critical for ensuring the continued safety of electrical installations in hazardous locations. Inspections should be conducted by qualified electrical professionals to identify any potential hazards, such as damaged equipment, loose connections, or inadequate grounding. Maintenance should be performed regularly to ensure that equipment is operating properly and that all safety features are in good working order. The NEC is updated regularly to reflect changes in technology and best practices. It is important to stay up to date on the latest edition of the NEC and to incorporate any changes into electrical installations in hazardous locations. Failure to comply with the NEC can result in serious consequences, including fines, legal liability, and, most importantly, injury or death. Therefore, it is essential to take all necessary steps to ensure that electrical installations in hazardous locations are safe and compliant with all applicable requirements. In summary, the requirement in NEC Section 500.8a on that Class 1 equipment shall not have any exposed surface that operates at a temperature in excess of the ignition temperature of the specific gas or vapor is a critical safety measure designed to prevent explosions and fires in hazardous locations. Compliance with this requirement requires careful selection of equipment with appropriate temperature ratings, thorough knowledge of the flammable substances present in the area, and adherence to all other applicable NEC requirements. By taking these steps, it is possible to ensure the safety of personnel and property in hazardous locations. To reiterate, this regulation ensures that electrical equipment used in these environments does not become an ignition source itself. The ignition temperature is the lowest temperature at which a substance will spontaneously ignite in a normal atmosphere without an external spark or flame. If equipment surfaces reach or exceed this temperature, they can trigger an explosion or fire. The equipment's temperature rating signifies the maximum surface temperature it will reach under normal operation, and it must be lower than the ignition temperature of the surrounding flammable substance. Hazardous locations are classified based on the type and likelihood of flammable substances being present. Class 1 locations involve flammable gases or vapors. Division 1 indicates continuous, intermittent, or periodic presence of hazardous substances under normal operating conditions requiring explosion-proof equipment. Division 2 implies presence only under abnormal conditions, allowing either explosion-proof or intrinsically safe equipment. Equipment markings include temperature codes indicating the maximum surface temperature and applicable class and division. For example, a T3C code corresponds to a maximum surface temperature of 160 degrees Celsius suitable for Class 1, Divisions 1 and 2. Electrical equipment generates heat during operation, leading to a temperature rise. This rise must be considered when determining the overall temperature rating to ensure it remains below the ignition temperature of the flammable substance. Other critical aspects include grounding, bonding, and sealing to prevent electrical arcs and sparks. Grounding and bonding equalize electrical potential, minimizing shock risk, while sealing prevents flammable substances from entering enclosures. Regular inspections and maintenance are crucial for ongoing safety. Qualified professionals should conduct inspections to identify hazards like damaged equipment or loose connections. Personnel working in hazardous locations require thorough training on flammable substance hazards and safety procedures. Staying updated with the latest NEC revisions is essential for compliance and safety. Failure to adhere to these guidelines can lead to severe consequences, including fines, legal liabilities, injuries, or fatalities. In conclusion, NEC Section 500.8(a)(1) mandates that Class 1 equipment must not exceed the ignition temperature of surrounding gases or vapors to prevent explosions in hazardous locations. This requires careful equipment selection, knowledge of flammable substances, and strict adherence to the NEC guidelines. By prioritizing these measures, you safeguard personnel and property in these sensitive environments. Proper classification of hazardous locations is vital. Firstly, Class 1, Division 1 locations necessitate explosion-proof equipment because flammable substances are routinely present. Secondly, Class 1, Division 2 locations may allow intrinsically safe equipment, where energy levels are limited to prevent ignition, but explosion-proof options are also acceptable. It is crucial to select equipment certified for the specific hazardous environment. Equipment certification ensures it has been tested and approved for use in the designated class and division. Verify the equipment's markings for the appropriate temperature code and hazardous location rating. The NEC further addresses temperature rise in equipment. Electrical equipment generates heat during operation, which can raise the surface temperature. The NEC requires this temperature rise to be considered when selecting equipment, ensuring that the maximum surface temperature remains below the ignition temperature of the surrounding flammable substance. Proper installation practices are equally important. Follow manufacturer instructions and NEC guidelines for wiring, grounding, and bonding. Grounding and bonding minimize the risk of electrical sparks, which could ignite flammable substances. Consider using explosion-proof conduits and fittings to protect wiring in hazardous locations. Regular inspections and maintenance are essential for maintaining safety. Schedule routine inspections to identify potential hazards, such as damaged equipment or loose connections. Replace any damaged or malfunctioning equipment immediately. Keep accurate records of inspections and maintenance activities. Training and education are crucial for personnel working in hazardous locations. Provide comprehensive training on the hazards of flammable substances and the proper safety procedures. Ensure personnel are familiar with the NEC requirements for hazardous locations. Emphasize the importance of following safety protocols and reporting any potential hazards. Regularly review and update training programs to reflect changes in technology and regulations. The selection of appropriate explosion protection methods is crucial. Explosion-proof enclosures are designed to contain any internal explosion, preventing it from propagating to the surrounding atmosphere. Intrinsically safe systems limit the electrical energy to a level that cannot ignite the flammable substance. Pressurized enclosures maintain a positive pressure of clean air or inert gas inside the enclosure, preventing flammable substances from entering. Consider the specific characteristics of the flammable substance when selecting the explosion protection method. Proper ventilation can also help reduce the risk of explosions. Provide adequate ventilation to dilute flammable substances and prevent them from accumulating to explosive concentrations. Monitor the concentration of flammable substances in the air and activate alarms if levels exceed safe limits. Regularly inspect and maintain ventilation systems to ensure they are operating effectively. Emergency shutdown systems can quickly de-energize electrical equipment in the event of a hazardous condition. Implement emergency shutdown systems that are reliable and easy to operate. Train personnel on how to use emergency shutdown systems and conduct regular drills. Regularly test emergency shutdown systems to ensure they are functioning properly. Fire suppression systems can help control fires that may occur in hazardous locations. Install fire suppression systems that are appropriate for the type of flammable substance present. Regularly inspect and maintain fire suppression systems to ensure they are ready for use. Train personnel on how to use fire suppression systems and conduct regular drills. By implementing these additional safety measures, you can further reduce the risk of explosions and fires in hazardous locations. Remember that safety is an ongoing process that requires constant vigilance and attention to detail. The key is to prevent the equipment from ever becoming an ignition source by ensuring its surface temperature stays well below the ignition point of the surrounding flammable materials. This regulation is crucial for preventing explosions and fires in environments where flammable gases or vapors are present. It mandates a strict adherence to temperature limits to mitigate the risk of ignition.